Hello and welcome. What we're going to do today is have a series of informational talks on Myers for Psychology, Myers Psychology AP Second Edition textbook, modules 23 through 24. This is set up for my students with PowerPoint, but everyone I think will enjoy the topics discussed here. We will be talking about sleep, dreams, and drugs as they apply to our States of Consciousness unit, which is Unit 5. So let's go ahead and get started. We've already, previously in our class anyway, at Lakewood Ranch High School, we've already covered the introduction of consciousness and hypnosis. So we have these three modules left to talk about. So we'll split them up into three different sections, again, sleep, dreams, and drugs. Let's start first with sleep patterns and sleep theories. In looking at the sleep patterns, we have to remember that the research on sleep patterns has been done only in the last 30 or 40 years in sleep clinics at universities and other research institutions around the world. And one of the things that we found is that human beings, like animals, have certain biological rhythms. So let's take a look at some of those. Probably none is more important, at least as a psychological term on the AP Psychology exam, than their circadian rhythm. Circadian rhythm has been a featured term on the AP exam free response section for a couple of times, at least out of the last 6 or 7 or 8 years. So let's take a look. Circadian rhythm, of course, is our 24-hour body cycle. And we have certain temperature changes that go through. We have some changes in blood pressure, different basically bodily effects that we have as we go through our 24-hour cycle. So circadian rhythm, which basically comes from circa, which means about a day, is our biological clock. And it's not exactly the same for everybody. There are some people who like to be up early in the morning and some people that like to go to bed at night, go to bed late at night. But in general, we actually have these biological rhythms that seem to are built into us as standard equipment, if you were. Of course, we also have other physiological rhythms, biological rhythms as well. Females, for example, have a 28-day menstrual cycle. There's the 24-hour, basically, alertness cycle, which is how much energy we have during the day. In many places, for example, we have a lull in the afternoon. That's why in many cultures there's a siesta or a nap time taken for that particular reason. And then our annual cycle, which kind of gives credit to seasonal affective disorder and other interesting effects of seasonal changes. This is actually from a video from a class in Florida, and we don't really have a lot of seasonal changes. But those of you watching elsewhere, I think you know that there are times where, for example, in winter, where you're could be very depressed. You don't see the sun for a long period of time, and so forth. And then the 90-minute sleep cycles, which we'll get into quite a bit, and you'll need to know all 4 of those sleep stages throughout that 90-minute cycle, and how we cycle back and forth throughout those sleep stages throughout the night. Of course, our biological clock also is individual. It's not everybody is exactly the same. So some people do like to get up early and get things done, and other people do stay up late at night. There's also an age issue here as well. Because, for example, teenagers, which the majority of you out there watching this are teenagers, getting ready for your AP Psychology exam, are basically, biologically, you should be going to sleep probably around, I would say probably 1 or 12 o'clock or 1 o'clock in the morning, midnight or 1 o'clock in the morning, and then you should probably get up around 9 or even 10 o'clock. Of course, schools do not really go on that schedule, and so consequently most people during, for example, first period at our school, very sleepy indeed. Animals have sleep needs as well, although the animal here on this slide is actually the dolphin, who doesn't sleep at all. Some of you may know this. The dolphin actually must voluntarily breathe air, so consequently they have to face the choice of either staying awake or drowning. So what they do basically is solve the problem by sleeping on just one side of its brain at a time. So technically the brain is never completely asleep. And that brain, that's the half that stays awake, controls breathing. Other animals vary throughout with regard to their needs, sleep needs. The hairy armadillo, for example, on this chart leads at 20.4 hours. The other part of the chart actually talks about whether or not the eyes are closed or open when sleeping. The burrowing animal, for example, sleeps with one eye open. And chimpanzee, dog, fruit flies actually have no eyelids, so they have no real technical eye position during sleep. And then the bullfrog also joins the dolphin with not having any sleep needs at all. This slide complicates things for people because when they look at it, we don't really understand it with regard to free-flowing sleep rhythms. In experiments done with subjects allowed to actually select the times of sleep and lighting in their laboratory room, the result actually is a 25-hour sleep rhythm. So a bit of trivia here: humans actually work on a 25-hour sleep rhythm when allowed to actually be able to choose when they want to go to bed and when they want to get up. In other words, having lighting on or off. The free running rhythm actually begins to advance around the clock, and so that's where we get that extra hour that seems to advance. And the rhythm quickly resynchronizes. As soon as periods of darkness were scheduled, which is the colored area, the rhythm quickly resynchronizes to 24-hour days. So let's take a look at sleep stages now, and a lot of this research was gained after the invention of the EEG, which you may remember from Unit 3 is the electroencephalogram. By measuring brain waves, we can see during nighttime, for example, that we do actually go through periods of different stages or different brain waves. So the wave patterns that you're seeing here are kind of like a seismograph where we have a printout of different kinds of waves. All right, and the moment at which you fall asleep here, we can actually see we have a rapid section here where we're awake, and then in the moment of sleep takes place right here. We'll talk about four different states of sleep, or excuse me, 2 states of sleep and 4 stages of sleep. So the 2 states of sleep are either REM sleep, of which there are 3 stages, and non-REM sleep, of which there's just 1. I need to reverse that, I'm sorry. That's REM sleep actually has 1 stage, and then non-REM has 3. Our definition of sleep is periodic natural loss of consciousness as distinct from unconsciousness. We're not being knocked unconscious or being hit in the head or whatever from a coma or hibernation or anesthesia. This is basically our own natural periodic time that actually does eventually end and we wake up again. So it's natural, it's reversible. Even if you're Rip Van Winkle, the famous story, he slept for 20 years, he eventually did wake up. It's probably the most dramatic of all the states that we actually look at in this unit because sleep is so different from our waking lives. And of course, sleep and wakefulness are the most obvious examples of circadian rhythm. Later on, we'll talk about the brain mechanism that is responsible for this sleep need, and it is called the suprachiasmatic nucleus, and it is located in the hypothalamus. It's a picture of a couple of Siamese twins, and they share the same blood supply. They do have separate brains, but one sleeps while the other is awake. Basically, as newborns, most newborns require upwards of 12 hours of sleep, and then those sleep needs are back down throughout the lifetime. We'll look at that in just a little bit with regard to sleep deprivation. In taking a look at the different types of physiological reactions that happen during sleep, we have basically several. Eye movements, of course, electrodes are placed here on the eyes. Muscle tension, there's electrodes placed on the face to actually measure face twitching and muscle contraction and so forth. The EEG patterns, of course, are taken throughout on the scalp, and those measure electrical activity in the brain. Now what we find is we have certainly a lot of different kinds of waves, but we can split these waves, at least for the ones that you are, the 2 that you're awake for beta waves and alpha waves. The delta waves are some of the deepest waves of sleep. So again, if we review the different types of sleep activity and how it's measured, we have the left and right eye movements, and we have EMG and EEG. Now, if you were participating in a study for, say, sleep apnea or something like that, they might be attaching a thermistor to your nose to measure how much air you're getting into your nose and so forth. But these are the major ones that researchers at Penn State was actually one of the first ones to actually study sleep, and a lot of the literature that we have comes from those early sleep studies in the 1970s at Penn State. So when we take a look at the chart here and we look at our sleep stages, we have the waking beta brain movements. So this is basically your brain awake. We then have alpha waves as you begin to lay down and start to get a little bit sleepier. And then we can eventually go, then REM sleep actually looks like this. Non-REM or stage 1 sleep looks like this, non-REM 2, and then non-REM 3, also known as delta waves. So what we need to remember is that beta and alpha are different degrees of being awake. REM sleep is its own state, and then we have 3 non-REM stages in the state of non-REM sleep. Somewhat confusing, but let's make sure we've got it again. Waking beta and alpha, non-REM sleep, 3 stages, and REM sleep, just REM. That's what it's known as. Now, you're going to need to know for probably your test in this unit that the different stages correspond with different types of phenomena that we can note. These are different things that happen in those stages. We also can begin to actually make the connotation between stages and certain sleep disorders, which we'll get to later on in Module 24. So, non-REM, we basically have non-REM 1, and that's where we have hallucinations. Now, not the kind of hallucinations you would have with drugs or anything like that. We call it hypnagogic sensations. It's basically when you're falling asleep and you got that drowsy, kind of really lazy type feeling where you almost maybe even have a sensation of falling, where you basically are in that sleep pattern where you're about ready to fall asleep. Now, it's during this period that we might have what are called false dreams. False dreams is the faulty sense-like perceptions that we have, that we think we're actually going into a dream right away. But actually it's your body shutting down and the changing of the stages that allow you to go into non-REM and REM and non-REM 2 and then eventually non-REM 3. So there's also something called a hypnic jerk. Maybe this has happened to you before. You're falling asleep and you just, all of a sudden you just seem to jerk and wake up. It's actually, or not necessarily wake up, but you feel yourself kind of jerk yourself awake. And the idea of the hypnic jerk is basically that, we are falling asleep, our muscles are contracting, and that's pretty much what it is a major muscle contraction as your body kind of relaxes. REM sleep, altogether different. REM sleep is where we have, and stands of course for rapid eye movement, which a lot of you probably are aware. It's also known as paradoxical sleep. Now the paradoxical part of it, okay, has to do with the fact that the muscles are relaxed, except for minor twitches in your face, which is just muscle contraction. But the other body systems are active. What other body systems? Well, heartbeat, breathing, brain activity. There's some evidence actually that you actually can have more brain activity going on in REM sleep than you actually do at some points during the day when you're awake. Now, looking at this chart, you can see how a typical night's sleep for young adults and older adults, and the number of hours are pretty much the same. I know, we all make jokes about older people needing more sleep and so forth. Actually, the reason they go to bed earlier is basically just a biological anachronism, but they also get up earlier. So the amount of time they spend sleeping is pretty much the same, okay? Especially when you consider the fact that they're getting up quite a bit during the night, possibly because they can't sleep as long, or they have to go to the bathroom or something like that. So we have the awake part, and that's where we're going through stage 1. Then we can go right into, we do not go right into REM sleep. That's a misnomer. A lot of people think, we go right into dreaming. Remember I said that the hypnagogic sensations are false hallucinations. They're not true dreams. True dreams usually only take place in either non-REM 3 or REM sleep. So basically in this 90-minute, or this is 1 hour sleep cycle, so it takes you about 90 minutes to actually get to your first session of REM. And as you can see, you basically go up and down through REM throughout the night. Now you'll notice something interesting. The delta wave deep sleep actually decreases throughout the night, and REM sleep increases throughout the night. There's a small period of REM, there's a longer period, even a longer period. So for those of you who think you don't dream, you have your best chance of actually capturing a dream if you were to awaken in this longest section of REM sleep here. That's where you have the best chance. And we'll be talking about REM sleep as part of Module 24 later on. Now in older adults, you can see there's a bit more of an up and down pattern here. And there are several different reasons for that, but we don't need to know that. Now on your slide in your PowerPoint for my students who are viewing this, you actually have some changes to make. Certainly make a change of the title. At one point there were 4 REM stages, but scientists have gotten enough information to actually understand that there's very little difference between what used to be called stage 4 and what is called stage 3 sleep now. So they've actually put those 2 sections together and eliminated stage 4 sleep, and now it actually is just known as stage 3. So there is no more stage 4 sleep. And that also this large patterns here are the delta waves, which is the deepest amount of sleep. Again, beta, alpha, and delta, okay? And I'd like everybody to say hello to my dog here. This is my dog Nala. There she is. Oh, can't see her. Okay, how you doing? Okay, bye-bye. You gotta go now. And beta, alpha, and delta waves are waves that are measured by the EEG. Again, alpha, the slow waves of a relaxed awake state. Non-REM stage 1, as we lay with our eyes closed, we're awake, highly relaxed state, basically characterized by these alpha waves, and they are basically large slow waves that are relaxing and falling asleep. As we fall asleep, we have a 50% decrease in alpha wave activity, sometimes known as drowsy sleep. And during this, we experience hallucinations and false sensory experiences. You may have even experienced the sensation of falling or floating. Also known as hypnagogic sleep, and generally, for at least even for teenagers anyway, 5 minutes of sleep. Stage 2, we want to remember a term called sleep spindles. Sleep spindles are a rapid bunching pattern of EEG waves that seem to take place and mark the difference between non-REM 1 and non-REM 2. Again, this is a stage where you're clearly asleep, and at this point, sleep talking and any other stage can actually, at any other stage, sleep talking can occur as well. You guys, sleep talking basically can happen at any one of these other stages, and if you actually were interacting with somebody and you thought you were having a conversation and they were hearing you and understanding what they were saying, that's kind of your imagination going away with you a little bit. They're really not having that conversation with you. And again, that's about a 20-minute section, 20-minute cycle. When we get to stage 3, that is the deepest amount of sleep, and that's your descent into slow wave sleep. The slow wave sleep actually begins, as I said, in stage 3. And it's at this point that somnambulism may occur. Somnambulism is the technical name for sleepwalking. And probably, depending on an average class size of 30, I usually have about probably 25% of my students who have walked in their sleep. Most people grow out of it, and of course it's certainly something that most people will report that they did, but no effects from it. I do need to mention, however, that there have been people who have committed crimes and done some rather unusual things while sleepwalking, and these are adults who actually have a sleepwalking disorder. And yes, some of them have even used it as a defense in a murder trial. I'll show you a couple of clips, a couple of newspaper articles on that later on. So these deep sleeps. This is a section, this is a time period where it's very hard to wake people up, and this is a time period where people are so hard to awake they may actually be very angry or startled when you do wake them up. And again, this also may be sleepwalking, but we also need to say that enuresis may take place. Enuresis is wetting the bed as well. I don't ask how many people actually experience that in my classes, of course. And most people, oh, well, I won't say most, pretty much everybody grows out of that. Night terrors is another thing that can be experienced in stage 3 sleep. Night terrors are not nightmares. A nightmare is a dream, so consequently it's usually associated